depending on how the question is presented, one way will be more straightforward than the other for solving that particular question. Now, that was the probability of one event. You may also be asked to calculate the probability of multiple independent events. And it's independent because the outcome of one doesn't affect the outcome of something else. So for instance, if I picked a red book on the shelf and then put it back, and then I went to go pick a book again, the probability of picking a red book is still 3/8. Like picking the red book the first time didn't change the likelihood in any way that I'd pick it again the second time. So to calculate the probability of two independent events, multiply the two probabilities together. So let's go back to our books on the shelf. So now I've got 2 blue books and I've got 3 red books. And again, I have just some other books that I don't know the color of. Okay, so here are my total number of books. What is the probability of selecting a red book and then a blue book? Well, I can see that my probability of a red book is going to be, I got 3 red books, that's what I desire, over 8 total books. Now, my probability of selecting a blue book has nothing to do with whether or not I pick a red book the first time, because I still have 8 books on the shelf. So I have 2 blue books, and I still have 8 books on the shelf, so my probability is 2/8. And to calculate the probability of doing both of these things, I would multiply the probabilities together. So 3/8 times 2/8 is 6/64. We can simplify that down into 3/32. So when you're asked about the probability of 2 events, if I want this and that, multiply those 2 probabilities together. And you can see here that this probability is much less than either of those individual probabilities. And that makes sense logically, right? The likelihood that multiple things will happen in the exact way that we expect them to is going to be much, much less than the likelihood of any of those individual things happening on their own, right? With no regard for anything else. So let's look at a couple questions here that are dealing with this probability concept. We want to know, what is the probability that it will rain all 3 days? Now, in this case, you can see that the probability has not been given to you as a fraction, but rather as a percent. Well, convert that percent to a decimal, multiply, and then convert back to a percentage. And that'll be how you answer question number 15. Take a look, unpause when you're ready to reveal the answer. My probability that it will rain on Tuesday is 30%. On Wednesday, it's 45%. On Thursday, it's 50%. So we can multiply 0.3 times 0.45 times 0.5. Again, moving the decimal place over to the left to convert that percentage to a decimal. Multiply that all together, and you have 0.0675. Now, at this point, you need to convert back to a percentage, and you can do that either by moving that decimal place over to the right or by multiplying by 100%, and you'll get 6.75%. It's important to notice you must convert this back to a percentage in order to answer this question correctly, because the answer choice wants it in a percent. If you had typed in 0.0675, this meant that you did a lot of good work, but you didn't finish the problem, because 0.0675 is not the percent, that is the percent as a decimal. Make sure that you're keeping those 2 concepts straight. Got another one here for you. I will go ahead and give you time to think through this one on your own. Pause the video and unpause when you're ready to walk through the work for question number 16. All right, Hartley's open a food truck business. Want to know how much will be earned on day 10? How much will the business earn on day 10? Well, on day 2, the business earns $112, and on day 5, the business earned $367. Now, Hartley assumes that the earnings are going to continue to increase at the same rate. So because we have a rate problem, we can figure out what that rate is. So over 3 days, the business earned a difference of $255. This is, think of our change in one variable over change in the other. Change in money over change in days. This will give us the rate of money per day. So $255 increase. So the increase per day then, divide this by 3, there's an $85 increase per day. So every day, Hartley earns $85 more than the previous day. So after 5 days, that increase will be 5 times that amount. And so after 5 more days, you're going to add that to what the business earned on day 5. So on day 5, Hartley earned $367. 5 more days at the same rate. So add 85 5 more times, and that will give you the total amount earned on day 10, or $792. Now, another way to think about this would be to think about it as a graph. If you are someone who finds it easier to think about this in terms of a linear equation, what you calculated here was the slope. So this increase per day, this rate of a linear equation, is also known as the slope. You can definitely find out more about that in the lesson on coordinate geometry. So change in y over change in x, and then you're looking for what is the value at, in this case, x equals 10, or day 10. All right, last question here. Let's take a look at 17. Douglas has received a 6% raise. Congratulations, Douglas. Now, we'll recall that there's 2 different ways to find a percentage increase. Think about which one is going to be the shortest way of figuring out his new monthly salary. Pause the video and unpause when you're ready to review the work for the final question of this lesson. Well, if Douglas's old monthly salary was $2,250 and he received a 6% raise, remember, you could calculate 6% of $2,250 and then add that to Douglas's old salary, or you could use that pro tip and do the one calculation option, which is to say, well, we want 6% more than 100% of his old salary, or we want 106% of the old salary. So you multiply the old salary by 1.06, and that gives you the new salary, $2,385. Now, if you did this question using the 2-step approach, you multiplied 2,250 times 0.06, remembering to convert that 6% into a decimal, and then added that to 2,250, you would have gotten the exact same answer. It may have taken you a little bit longer, but you would have still gotten the right answer on test day, and that's really what counts. We have covered a lot in this lesson. You should now feel more comfortable calculating the dimensions of various 2-dimensional figures, including the perimeter, the circumference, and the area. You should now understand some of those concepts that we dealt with in terms of rates, ratios, and percents, using them in terms of data, using them to calculate probabilities, as well as doing some of those statistics by finding the mean, median, and mode of some of those data sets. You know that your practice doesn't end here, so continue to practice outside these sessions to ensure test day success by completing additional practice. If you have any questions between these sessions, remember you can always reach us to get one-on-one support via email at gedhelp@kaplan.com. That email is checked every day except for Fridays and holidays. Thank you so much for joining me for this geometry lesson, and we hope to see you back in future GED live sessions real soon. Good luck on the GED test, and happy studying.